only doing one section today. One section. But square roots are not always that easy, so that's why we're doing one section today. We're doing square roots.
I think that's easier
Than factoring? The first section was okay. So we're going to be solving quadratics by finding square roots today.
Is it different?
It's a little different. You don't have to factor. Thank you. Ashley? Ashley? She's not here today. Oh. I thought I would have her on B-Day. Oh! Okay, so we're going to go on. Our goal is just to solve quadratic equations by finding square roots. Just type. Okay, everyone ready? Elton? Because she needed to go? Why to solve problems about astronomy, as in problem 39. And yes, you have to do 39 on your homework. But I actually show you how, an example of how to do it, so if we get to it today. It's not really long, but I made lots of slides because I only put a few problems on every slide. So we may skip some depending on how quickly you guys get it. Okay? Good? Okay. So we have a whole bunch of keywords, some key concepts today. So before we even get to work on it, we're going to talk about vocabulary and concepts today for a bit. Okay. So the first one is square root. What's a square root? Does anyone know what the definition of square root is? It's not half of the number. Okay, yeah, that's closer. So if b squared equals a, then b is the square root of a. Not half. It has to be b squared. So it's the same number times the same number. That's not half. It's only half on 4. It's the only number that works on. So the square, yeah, correct. So if I had 5 squared equals 25, then 5 is the square root of 25, right? Okay? Radical. It's an expression of the form the square root of s or the nth root of s, where s is a number or an expression. And yes, we haven't dealt with nth roots yet, and I think that's in the next couple chapters. Okay? So, right now we're only talking about square roots. Nth root. Nth root. And then we have a radical sign. Well, the radical sign is just a little square rooty thingy. Square rooty house, whatever you want to call it. And the last one on this slide is radicand, and that's the number underneath the radical sign. Or expression. It can be the expression also. But right now we're only dealing with numbers. Any questions on these 4 words? Fairly simple? Yes. Huh? Yeah, they're all underneath the square root. Yes. Do you guys know if most radicals are oh my gosh, the word was just right there. Rational or irrational? Most of them are irrational. Only the perfect squares are rational. Good. Meaning I can put them into numeric form. The square root of 25 is 5, right? So, which comes to a whole number. Most square roots go into a non-repeating, non-terminating decimal, which means it goes on forever. Right. The square root of 26 would just be, yeah, 5 point blah, 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 on forever. So that is not a rational number. That's an irrational number. Okay. 2 more words and we're done. Rationalizing the denominator. Now, in algebra, you did do this very shortly. Okay, for a short period of time, you rationalized the denominator. And it's kind of a long definition. It's the process of eliminating a radical expression in the denominator of a fraction by multiplying both the numerator and the denominator by the correct radical expression. And it depends on what the denominator is by what we're going to multiply it by. Okay? So when we get to that point in the lesson, we'll talk about that more. But needless to say, there can be no square roots in the denominator. None. So when there is, you have to rationalize the denominator. And then the last one is conjugates. And a conjugate is the expressions a plus the square root of b and a minus the square root of b, where a and b are both rational numbers. And they don't stop. They just keep going, and you got to go. They don't stop either. They don't pause. They don't do nothing. You just got to write. And then you write. You don't comprehend until you go back and read it later. So all you're doing is writing. That's college. You record it. Record it. At the same time. Then if you hear something, you go to that section again. Why most professors let you bring a recording equipment to class? Probably. You just have to ask your professor. Okay, everyone good? Okay. Well, they're professors because they have their doctorates or whatever, so. Okay, we're going to talk about the key concepts now, and there's 3 of them that we're going to talk about today. This is the first one, and it's the properties of square roots. As long as A and B are greater than 1. Next time we'll talk about A and B being less than 1. And that's when we get into imaginary numbers. I know some of you have heard about those, okay? But we'll get into that next time. So the first one is the product property. And that says, very simply, that the square root of A times B equals the square root of A times the square root of B. So I can separate them out or I can put them together. Either way. And how we would use this is if I have the square root of 27, that equals the square root of 3 times 9, right? Which is the square root of 3 times the square root of 9. And what's the square root of 9? 3. So my answer would be 3 square root of 3. Huh? You remember it? Yeah. This lesson, it really... Huh? Yes. Okay? It really comes in handy if you know your perfect squares, because that's what we're looking for. 4, 6, not 6, 4, 9, 16, 25, 36, right? So those are the ones that you want to look for when you're doing this, are perfect squares. What perfect square will go into that number? Okay? And then we have the quotient property. And that says the square root of A over B equals the square root of A over the square root of B. So if I have the square root of 25 over 4, that's the same as the square root of 25 over the square root of 4, which equals 5 halves. Okay. Fairly simple properties. Not too bad. The properties are okay. No, you don't get it? Which one don't you get? So if one of them wasn't a perfect square, so like say, let's say 17 over 16, square root of 17 over the square root of 16 would equal the square root of 17 over 4. Now, when there's a square root in the denominator, that's when things change. When this 17, if this was switched, and we'll talk about that in a little bit, okay? Okay. Good question, though. Erin, okay? So. I am going to show you in just a little bit. I don't want to confuse you too much right at first. Is that okay? Hold on. Who's holding? Oh. Done? Okay. So the next one we're going to talk about is simplifying square roots. Okay? In your book, they don't really have this as a key concept, but you really need to know how to do it since that's what we're doing. We're simplifying square roots today. So we're going to talk about it. There's two things you have to know when we're simplifying. The first one is that there are no perfect square factors other than 1 in the radicand. So inside the square root, there can be no perfect squares other than 1. 1 times 1 is 1. So, and that 1 is a factor of every number. So that can be inside. And the, and the second one is there's no radical in the denominator. There can be no square roots in the denominator. This is why I've made this just one lesson, not 2 sections together. Okay. Everyone okay with those 2 rules? So when you're simplifying, you need to make sure you check these 2 rules to make sure it's totally, completely simplified. No square root in the denominator. Yeah. A radical is a square root, right? In the denominator. Okay. Aaron, okay? Ready? Edwan, not ready yet? Okay. No, I'm just giving him a hard time. Lovely. Okay, and the last concept is about dropped objects. So this ties into physics. If you've been in physics, you know about this. If you're in physics now, I happen to know that you've worked on it already, somewhat. And if you're not in physics yet because you're a freshman, you'll be in there next year, and you'll be using this concept. Chemistry. Oh, no, physics is your junior year, huh? Physics is junior year. Sorry. So, I think so. A, what? Yeah, I think so. Okay. So what it says the following function, if any dropped object, you drop an object. Okay, it says the function h equals negative 16t squared plus the height, with h being the height in feet above the ground after t seconds, models dropped objects on Earth. Notice it says on Earth, okay, because when we start talking about other planets, it's a little different. And that's actually problem 39 today that you have to do. Okay? everyone ready? Excellent. Okay, now we're going to start working. Super hard stuff. Ready? I know I'm being sarcastic. The first couple really are not that hard, okay? We're just going to use in fact, we already did the square root of 27. I chose that as my example. So we don't have to do that one again. Let's do this one. Square root of 98. I did square root of 27 when I was doing the properties. Right? Did you write it down? Yeah. So do I need to do it again? Okay. I can do it again if you really want to write it down twice. No? Okay, cool. So if I have the square root of 98, I want to find a perfect square that goes into 98. I know 2 goes in there, but 2 is not a perfect square. I'm looking for one of the perfect squares that goes into that number. So our perfect square, 9 goes into 98. I don't think so. 9 goes into 99. So, right? So we have 4, and not 1, because 1 goes into everything, so we're not even going to count 1. Okay, so 1, we have 4, 9, 16, 25, 36, 49, 64, 81. That's all we need for now. 100. 44? How about 49? 49. 49 does go into 98 2 times. So this becomes the square root of 49 times 2, which equals the square root of 49 times the square root of 2, which equals 7 square root of 2. Now, I really need to ask you guys this. Do I really need to do this step? No, because if you know this, just as long as you know that this works, okay? But I can go from here directly to here, right? As soon as you have your perfect square. That's cool. You don't have to do all the steps, okay? Especially since this one is kind of redundant, right? Square root of 49 is 7, and then the square root of 2 is still left underneath there. Okay, is everyone okay with that? All right. So let's go to this one. What do you think we're going to do? Are 10 or 15 perfect squares? No. So what do you think I need to do? I can times them together. Very good. So this becomes the square root of 10 times 15, right? Which is what? The square root of 150. And what perfect square goes into 150? 25. Because we have $1.50 and quarters go into $1.50. That's how I think of that. Okay. And how many quarters are in $1.50? Okay. Because there's 4 in $1 and then 2 makes this, huh? The square 150 is not a perfect square, so I need to find a perfect square that's in there. Yes, it's going to be 5 square root of 6. Okay, so that's one way to do this. I can do it another way, which may be a little shorter. Who knows? Okay, but I do know if I start here, I do know that this is the square root of 5 times 2 times 5 times 3, right? Isn't that 10 times 15? Okay, right? And a square root means I have to have 2 of the same number to bring one of them out, right? I have 2 5s in there, so I can bring a 5 out. Okay. Some people see it that way. I just show it. If that bothers you, don't look at that one. Do it the other way, right? But some people look at that and say, oh, that makes sense. Okay? So I kind of like trying to show you different ways. Okay? So try this one. You guys try it. And you know when I really like this way? Is when I don't know how to multiply 8 times 28, and that's really ugly multiplication. This way makes a little bit more sense. Right? Okay. So there's times when each way is easier, right? Okay. Is that what it is? 24, sorry. 224. But then I have to do some division. I really don't like doing division. So I'm going to go, I'm just going to start with my factors. What's 8? 8 is 4 times 2. And 28 is 4 times 7. So now I have 2 4s in there, and that means I can take one of them outside, and I'm left with a 2 and a 7, which is 14. Right. And because 224, you have to start with the numbers going in. So you see the difference there? Okay, I know that doing the 10 times 15 is easier to multiply because $1.50 and quarters in there is pretty easy, right? But when you get to harder multiplication, the factors are easier. Is everyone okay with that? Question? You think you'll be okay with that one? Okay. So now, and I'm sure that nobody heard the last few things I said because I was not talking into the mic. Oh, that's okay. I record it because, like, there's people that are missing. So I put it on my YouTube channel and then on my website, and they can go in and watch the lesson. Only you don't get to see me being in the way. You just get to see the board. Yes. You still have to do the reflective journals. No. Because that does not, the reflective journal is for me to know that you understand what you're doing. Okay? So if you go to Miss Campbell's website, that doesn't tell me that you know how to do the work. Okay. So let's do this one. Can anyone just tell me what the answer is? 3/8. Yeah, the square root of 9, right? This becomes the square root of 9 over the square root of 64. And just like the other ones, if we can tell, do we have to do this step? No. The square root of 9 is 3. The square root of 84 is 8. 3/8. Done. Not too hard, right? No, because the square root of 9 is 3 and the square root of 64 is 8. So there's no square roots left. Those are both perfect squares. Okay, what about the square root of 15/4? What would that be? No, it is not 3 and 5. It's not 15 over 2 either. The square root of 15, yes, over 2. That's it. Because there's no perfect squares in 15, right? It's only 3 and 5, or 1 and 15. There's no factors that's a perfect square, so that just stays the same. Remember our rules for simplifying? We can have a square root as long as there's no perfect squares in there and it's not in the denominator. Okay? So let's try this one. Manuel, what's the answer? Yeah, perfect. Super hard so far, you guys? I know, totally and completely, right? You know me too well. Okay, what's the square root of 36 over the square root of 36 over 49? Yeah, 6/7. Perfect. Excellent work, ladies and gentlemen. Super hard, right? Okay. Now we're going to get a little harder. I'm sorry, you know it gets harder all the time, right? So we still want to simplify the expression. Here's my expression I want to simplify. Can I take anything out right away? No. So I can break, if I use my property, it says the square root of 6 over square root of 5. So simplifying, there's no perfect square in any of the square roots. But there is a square root in the the denominator, right? So I have to get rid of that. And this is where rationalizing the denominator comes in. We're going to multiply by 1. I can multiply any number by 1 and get the same answer, right? Is that right? Yeah. But I'm going to multiply by a special one. Can anyone guess what that 1 is going to be? It's not going to be an imaginary one. It's going to be the square root of 5 over the square root of 5. The only way to get rid of a square root is to make a perfect square, right? And 5 times 5 is, and the square root of 25 is, no more square root in the denominator. Okay? So, yes. Hey, honey, I'm teaching right now. Can I call you back? No, it was not him. Okay. No, not my Florida fiance either. Okay, so 6 times 5 is, well, I have to, isn't this 1? So all I did is multiply by 1. Does that change my thing if I multiply by 1? It's just a special one, right? Right? I can multiply anything by 1 and get the same thing, right? So I want to, what's 6 times 5? And what's 5 times 5 is, and the square root of 25 is, right. Everyone okay with that? Not super hard yet? Okay, try this one. Try. You can talk to each other and help each other, you know. Yes, stop. I am going to grade the projects this week. Okay? I can't wait to read your conversation, Dalton. It's been just, I've been thinking about it for so long. It's just been, I'm just thrilled to read it. Okay. So this becomes, do you guys want me to do it or are you still working on it? Just do it? Why you can't do it? So what am I going to multiply by? Not 12, the square root of 12. So the square root of 12 over the square root of 12. Yes, by the denominator, because you want to get rid of the square root in the denominator. And 12 happens to be 4 times 3. Everyone knows that, right? Okay. Over, yes, honey. No, I'm not. No, I didn't do this one differently, honey. Why? I just didn't multiply. I multiplied here. 6 times 5 is 30. Aren't I multiplying 17 times 12 right here? Am I doing anything different? Okay. I did this because I know that there's a perfect square in 12, right? 4 is a perfect square. So what comes out? What's the square root of 4? 2 times the square root, 17 times 3. Anybody? Does anyone know what 17 times? Is it the square root of 4 too, honey? It's not 5. 17 times 3 is not 5. Thank you. It's 51. All over 12. Can it be simplified any further? Are we done? Yeah, what? Yeah, it can be simplified or yeah, we're done. How'd I get the 2? Because the square root of 4 is what? 2. If there's a perfect square in here, you have to take it out. Okay? Okay. Well, see, okay. That's fine. Okay? But I did it this way because I know that 4 is a perfect square. right? So I know that 4 is my perfect square is going to come out, right? So I could actually write this as the square root of 17 times the square root of 4 times the square root of 3, right? According to the property, all over 12. The square root of 4 is what? 2 times the square root of 17 times 3, which gives me this one right here. Okay? That way I don't get the great big number where I have to divide, right? Okay. Then I do have to simplify, you guys. 2 goes into 2 once, and 2 goes into 12 6 times. So this is the square root of 51 over 6. You have to simplify. Simplify. Yes, you can simplify those whole numbers. Well, it doesn't cancel out, honey. 2 goes into 2 one time, and 2 goes into 12 6 times. I simplified, yeah. When you simplify fractions, you divide, right? Okay. Yes. Yeah, that's 12. Sorry. All the rest of it are 12. Why would I change it all of a sudden? No, you guys are confusing me. Okay. Are you done, Manny? Oh, yeah, we're not done yet. Yeah. Not really. Yeah, I don't know. Okay. No, we're not finished. If you'd like me to stop now, I can, and you can figure it out on your own. Please quit asking me when we're done. When we're done, I'll tell you. Thank you. Okay, there's a square root in my denominator. I cannot multiply by the square root of 6 over the square root of 6. Because the denominator is not, the square root of 5 over the square root of 5. Because this is a expression, right? So I have to multiply this by an expression. Not minus 5. Plus 5. Yeah, this is where the conjugates come in, right? So I'm going to multiply 7 plus the square root of 5 over 7 plus the square root of 5. It's still 1. I'm still multiplying by 1, right? Okay. Now, if this was positive, then I would multiply by the negative. Yeah. Okay. Why? Right? Because this is 7 minus the square root of 5 times 7 plus the square root of 5. And if I FOIL it, right, or distribute, 7 times 7 is 49. And 7 times the square root of 5 is 7 square root of 5 minus 7 square root of 5. Oh, those go away. Plus 7 minus 7, right? And then minus the square root of 5 times the square root of 5 is square root of 25, which is not square root of 5. 5. And that's why we do the opposite signs, because that takes care of all my square roots. Okay? So that's my denominator, right? My numerator, I need to multiply negative 6 times negative 7 is what? Oh, yeah, negative 6 times positive 7, sorry. Negative 42, and then negative 6 times the square root of 5. Good. All over negative 5. Oh, not negative. What am I talking about? Negative 5. Where did that come from? It's 49 minus 5. 42, honey. 49 minus 5 is 44. What, this? If you know what the answer is going to be no. Yeah, I know. If I looked at this, I know that it's going to be 49 minus 5. I don't have to do this. It's going to be 49, this squared minus whatever's in the square root. Always. Okay. Because 6 times 7 is, and 6 times the square root of 5 is, so it's square root of 5. 49 minus 5 is, okay? Can I simplify it any further? How? I can simplify it further. Why? Because all of my 42, 6, and 44 are all what numbers? Even numbers, and what goes into every even number? 2, so I can simplify it by half. So what's half of 42? And what's half of 6? And what's half of 44? There you go. Now we're done. Okay, the next one you're going to do on your own. Do you have your book? And a note. Okay. Everyone good? Okay. Go. gives me 8 square root of 11 plus 27. I still have a square root. I want to multiply to get rid of the square root. Okay, Carla? If I have a positive and a negative, then this becomes a one becomes a minus, right? And minus and plus make it go up. The middle terms go away. Then I get 16 minus 11, which equals 5. You okay with that? So this always the opposite sign. Yes. So the first one was minus, we did plus. This one's plus, we want to do minus. We always want to do the opposite. Okay? So then mine becomes 8 minus 2 square root of 11 over 5. Yeah? Okay? Okay, do this one. Maybe I'll have Dalton come up here and do this one on the board for us. Because he's so good. Taking pictures of everybody. Yeah. Okay, Dalton, you're up. Let's go. Let's go. But no, come do it. Yeah, you do it just like the past two ones we just did. Maybe if you were listening instead of taking pictures, you'd know. Okay. So what am I going to multiply by? Oops. 9 minus the square root of 7, right? So what do I get? Negative 9 plus the square root of 7 over 74. 81 minus 7 is 74. Yeah, 9 times 9 is 81. Minus 7. 74. Not too hard, right? Cool. Now, we really haven't... Oh, we're not going to do that one. Sorry, we're going to go move on. We only have a few minutes left because people have been slow. So we need to solve. This is what the whole thing is, to be able to solve equations, solve quadratics, using square roots. So now we're going to do this. I need to solve this equation. So I need to get the x by itself. Just like if I was solving it was x by itself, I need to get the x squared by itself. So what do I need to do? What? Divide by 5. And x squared equals what? How many nickels and 80 cents? 16. And then how do I get rid of a square? How do I undo a square? I square root it. Yep, and if I'm going to square root one side, I have to square root the other side. And x is going to equal what? Wrong. It's going to equal plus or minus 4. Why? Right? Because I knew that was going to be the next question. How is it plus or minus 4? Well, what if x equals 4, what does x squared equal? 16. If x equals negative 4, what does x squared equal? 16. There are two answers, because a negative times a negative is a positive. So when I'm solving, how many answers is there going to be? 2. We should know this because this is a parabola, and how many times does it cross the axis? 2. There will be 2 answers, right? 2 answers. Okay? So you guys do this one. Woo! I know. This one's super hard. Equals what? What am I going to do? Okay, hurry. Right, so what do I need to do? Good. Yes. Z equals 36. Square root both sides, and Z equals plus or minus 6, not 9. I'm not sure where he got the 9 from. Right? Not bad? Okay, last one. We're done. Now he says, oh, I don't like this one. Oh, I don't get this one, right? This one's much harder. I still need to get my squared alone, so what am I going to do? Can I multiply before I do exponents? No. So I'm going to get my squared alone, so I'm going to divide by 3. And I get x minus 2 squared equals 40 thirds. How do I undo a square? I square root it. So if I square root this side, I have to square root the other side. X minus 2 equals the square root of 40 over the square root of 3. Can I have a 3 square root in my denominator? No, so what do I need to do? Not by negative 3. Square root of 3 over the square root of 3. So then I get x minus 2 equals, what's 40? What times what is 40? 4 times 10, good. Times 3, right? All over what? 3, good. Right? Everyone okay with that? Yes, honey. Well, this is squared, right? How do you undo a squared? Square root. Okay. So then I get x minus 2 equals, and of course it's got to be 2 answers, so it's going to be plus or minus, right? Plus or minus what? What's my square root of 4? 2. And what's left inside the square root? 30 all over 3. Are we almost done? Well, is x by itself? What do I need to do? Add 2. And I'm not going to I'm going to add 2 over here, but I'm going to add a special 2 because it's a fraction, right? 6 thirds. So that gives me x equals plus or minus, oh, no, sorry, not plus or minus yet. 6 plus or minus the square root of 2. Oh, ay vey, muy Dios. 6 plus or minus 2 square root of 30 all over 3. Done. Yes. This is a long problem. Okay. Well, I have to make a denominator of 3, right, before I can add them. So 2 times 3 is 6, so I get 6 thirds. Right? Okay. No, I'm sorry. That was a mistake. Yeah, it's just a dot. Okay. And it looks like we didn't get to the last question because we're going to run out of time. So, and it was a story problem. But there is an example in your book exactly like this problem I was going to do. Okay? Exactly. And it's exactly like your homework. So this part is for simplifying square roots. This part is for solving. Okay? So anybody want those codes? Really, there are people writing them down. Maybe someone didn't ask so many questions. That's how I teach. Okay, everyone good now? Huh? You know what? I will go when everyone's done. Okay. Homework. Page 269, 4 through 40 even, 21 and 39. 22 problems, 21 problems. Because we start at 4 instead of 2. Hmm? Oh, you have to write the right page.